I'm Anil Kumar. Welcome to my series on discrete functions. Here is a very interesting question based on sequences. This type of question has been asked in many test papers, including IIT JEE. Question number 1 is, write the first three terms of the sequence defined by the following recursion formula. T1 equals to 2, Tn plus 1 equals to 2 to the power of Tn, where n is greater than or equal to 1. Question 1b. What is the first term in the sequence greater than 10 to the power of 10,000? You can always pause the video, answer the question, and then look into my suggestions. So let's begin with the series first. We are given T1 is 2. Okay, so first term in this sequence is 2. And we are also given the formula, that is the next term, Tn plus 1, could be found by writing 2 to the power of previous term, right? So that is what it is. So T2 should be what? T2 should be 2 to the power of 2, which is 4. T3 should be equal to 2 to the power of 4, which is 16, correct? So that is how we can get the first three terms. Now, second part of this question here is, what is the first term in this sequence greater than 10 to the power of 10,000? Now, that is kind of tricky. To find this answer, we should know that what is 2 to the power of 10? You know kilobytes, right? So binary system is based on 2, and 2 to the power of 10 is 1024, right? So that is the key to answer the particular question. Now you can actually pause the video, answer the question, and then look into my suggestions. Okay. Now how do we do it? So we have already found three terms. Let's find the fourth and the fifth term. So t to the power of 4 will be what? It will be 2 to the power of 16, right? Previous power, 2 to the power of 16. How much is that equal to? Let's calculate. So 2 to the power of 16 is equal to 65536. 65536. Okay, let's continue and find what T5 is equal to. Well, that should be 2 to the power of 65536. And if I do 2 to the power of 65536, what do I get? I get error, right? So using calculator, I get error. So I'm not very sure what this number is. Definitely, this number is a huge number. Perfect. So anyway, the question is interesting. You cannot really use a calculator to find this solution, right? So that's what it is. Now let's try to figure out, after all, what is t to the power 2 to the power of 65536 is. So the fifth term where we are stuck is kind of like this: 2 to the power of 65536. Now to give us an idea, what we could do here is we could round this up as we could write this as 2 to the power of 65530 plus 6, right? Well, there is a reason of doing it like this. Reason is that I could actually now write this as a multiple of 10. See, we need 10 to the power of something, right? And we know 2 to the power of 10 is more than 1000, okay? Okay, so we can say that this term 1024 is actually greater than 10 to the power of 3. It is more than 1000, right? Okay, so rewriting this, we could say 2 to the power of, this is 10 times 6553, right? 6553, and plus 6 means times 2 to the power of 6 using exponents, laws of exponents, right? So that gives you an idea that we are really working with a number which is pretty high, and that's the reason why we got this error in our calculator, right? We're looking for a number 10 to the power of 1000. Now, 2 to the power of 10 and then something, and 2 to the power of 10 is greater than 10 to the power of 3. So if I replace this part as 10 to the power of 3, right, then we know clearly that this number is greater than that number, right? So this number is greater than, so our term t fifth is definitely greater than, since 2 to the power of 10 is greater than 10 to the power of 3, replacing 2 to the power of 10 by 10 to the power of 3 and writing the same things, which is 6553 times 2 to the power of 6. What we get here is something to the power of 10. Do you get an idea, right? So now what is this? Well, that means that fifth term is greater than 10 to the power of 3 times 6,000. Okay, 18,000. So that's a huge number, right? So if you multiply 3 by this, what do you get? Well, it is greater than 10 to the power of 3 times 6553. Let's use this. 3 times 6553 is equal to 19659. 19659 times 2 to the power of 6, okay, times 64. So that shows that the fifth term is definitely greater than 10 to the power of 10,000, right? This is almost 20,000, correct? So 10 to the power of 10,000 is far greater. So the answer here is that the first term in the sequence greater than this number is the fifth term, T5, right? So we get our answer, and that is fifth term is greater than 10 to the power of 10,000, right? So I hope that really helps, and this particular example, I would like you to watch it once again, understand the concept, and the concept which we have used here, that 2 to the power of 10 is 1024, which is greater than 1000, helps in solving such questions. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.